and an equation. So those are the three different ways we're going to represent all these different situations. So first one, just remember that all of these problems are not the actual problems in your packet. I created different problems. So if you notice, this is Salvador's, yours says junior, and that says 15 cents, whereas yours says 10 cents. So these are all different problems. So don't like copy this like all the way through. Otherwise, then I know you just copied my video. I want you guys to use the video to understand how to do the problem. So you could watch one problem at a time, and then right after you watch that one problem, work on it, and then move on to the next one. And obviously, you don't have to watch every single one of them. You can skip ahead in this video, even though it's an Edpuzzle. You can still skip ahead. I'm not like putting the non-skipping controls on, so you can kind of use it for whatever you need. Okay, so Salvador is saving money in his piggy bank. He starts with 15 cents. That's a key word, starts with 15 cents, and adds 3 pennies each day. So each day he's adding 3 pennies. Okay, so he's going to constantly add 3 pennies every day. So that's the rate of change. That's our M, is 3, or 3 pennies per day. Whereas our B is, which is that number we start with, or our y-intercept on the graph, that's 15. That's the number we started with. Now to start with the table, remember that we always start with x equals 0. Okay, that's our starting point, and our starting point is 15. And then we're talking about how many pennies he's adding each day. So that means that the x values are going to be the days. Okay, and then the y values are going to be the pennies. And we'll just put cents, like a little cent symbol over the top, just to remind us what those things are. Okay, after 1 day, he gets 3 more pennies, 18. After 2 days, 21 pennies. After 3 days, 24 and 27. Okay. So there's your table. Now let's represent it on a graph. Now, in order to put this on the graph, notice how the biggest number is 27. There's definitely not 27 squares here. So we're going to have to adjust the scale of the y-axis. Now, the x-axis, I'm just going to still go by ones. Because if you look at the x, it's just going by 1, right? So that has plenty of room to write 1, 2, 3, 4. Now, for the x-axis, it's going by 3s. I'm sorry, the y-axis. It's going by 3, so that's what I'll use what I'll use for my scale. I'll go by 3, then plus 3 is 6, then 9, then 12, 15. And for every problem, you can always adjust the scale however you want, okay, to be able to fit all your data in there. Okay, so now I'm going to plot each point. So 0 and 15, there's my first point, right there. Then 1 and 18, right there. 2 and 21, 3 and 24, and then 4 and 27. Notice it makes this nice straight linear line, okay, starting right at 15 and then continuing to go up to the right. Okay, so there's our graph. We represent it on the graph. Now we want to write an equation. Remember that we're always using the equation y equals mx plus b for linear situations when you're just adding something constantly. Okay, so then it's going to be y equals your m, which is 3, x plus the b, which is 15, which again is whatever number you start with. Okay, so now go on to the next one. Okay, so Zane needs to cut a smaller piece from a 50-foot long pipe. So like a pipe from, maybe he's doing construction on a house or something, and he needs to cut the pipe up to fit in different parts of the house. Okay, and he's going to cut it up piece by piece. So if you think about it, as he's cutting up this 50-foot long pipe, that piece is going to get shorter and shorter every time. Okay, so it says create multiple representations, again, table, graph, and equation. Okay, with the x values that are the length of the piece that Zane cuts off. Okay, so the length that he cuts off will be your x value, and the y value is the length of the piece that's left. Okay, so let's first of all figure out what our m will be after. Okay, because we don't really have, it doesn't tell us, oh, he's cutting off 2 feet every time, or he's cutting off 1 foot every time. Looks like we're going to have to figure that out for ourselves. But the starting point is 50. Remember, I told you that x is equal to 0 at your starting point. Okay. Another thing I'm going to do with this type of graph, what I'm going to go ahead and do, actually, we'll wait till we get there. Okay, so let's say I'm looking at the graph and I notice that it's going by 5s. So why don't we go by 5s here? Okay, so that it matches up. All right, so you notice how like these two graphs here and here already have a scale. So let's go with that. So here, since I'll follow the x-axis and it's going by 5, so I'll go 5, 10, 15, 20, 25. Let's just go there for now. And so what that means is that after 5 feet are cut off, how much do I have left? Well, 45 feet. So I just cut off 5 feet. If I cut off 10 feet, I got 40 feet left. Cut off 15, I got 35, and so on. Cut off 5 more, 30, 25, and it just keeps going, right? 20, 15, and I can end my table here at 10. All right, so that's 30 feet cut off, 35 feet are cut off, and then 40 feet are cut off, so naturally I should have 10 feet left. Okay, so again, this is how much you cut off, and this is how much feet you have left. Okay, so we'll say the length cut, I want to label my axes. That's the length cut, and then this is the length left over. All right. Okay, so now here, if you notice that we're kind of going down, right, by 5s on the right. Okay, so here we're going down by 5, so -5. On the left, we're going down by, or sorry, we're increasing by 5. Okay, so to get the slope, I'm going to take my change in y and my change in x, and I'm going to stack them on top of each other. Because remember that your m is basically your change in the y over your change in x. So basically, for every foot I cut off here on the left, I lose a foot, right? So really, it's just -1, or if I'm looking at it, it's -5 over 5, which is -1. Okay, and you'll be able to see that in the graph when we plot these points. If that's a little confusing to see that in the table, you should see it over here, and I'll show you why. Okay, so first at 0 and 50, well, I can't fit that on my graph, and actually I can't fit 45 or 40, 35, so I'm going to have to actually start with 30. So at 20, we're at 30. 25 is 25 itself, and then 30 is right here. Okay, and I can't go any further than that, right? But the graph actually started somewhere way up there and kind of came down here. So if I was to make my own graph, to be honest, I would probably make it go all the way up to 50 so that I could start there at 50. Okay, but it doesn't happen to do that. All right, so this, obviously, we wouldn't be able to determine like where it started and where it ended on this particular graph, okay? So now, but notice, again, remember rise over run when you're looking for slope? We're going down by 5 and over 5. So there's that same -5 over 5 that I was telling you about. You have rise over your run, which equals -1. So you can see it in the graph, or you can see it in the table over here. Okay, so now we're going to represent in an equation. Our m, we figured out, is -1. And our b is our starting point, 50. And remember, you don't have to put a 1 there. So I'll just put -x plus 50. Okay. Which of these represents the situation the best? Well, in this case, I don't really like the graph because I can't see everything. If I made a better graph, maybe it would have been good. The table, I don't know. I think that shows kind of like where we started, and possibly if we went a couple more spaces, that it showed where it would end. So I don't know. To be honest, it's kind of a matter of preference for me. I like this one better. And you guys might have different opinions. Okay? All right, so let's go to the next one. Okay, so now Angela planted an apple tree in her backyard. When she planted the tree, it was 3 feet tall. She notices sorry about that. When she planted the tree, it was 3 feet tall. So when she planted it, think about that. That's the beginning. So when she planted it, it was 3 feet tall. So there's your starting point, or your B. She notices that it has been growing meaning that it's going to increase, right? So it's going to be positive. It's going to increase 4 inches every week. Okay? So then that's how you can figure out what your B is and what your M is. Okay, so create an equation. So let's start with that. Well, we know our M, 4, and we'll just use X. And then we know our B is 3 feet. So 4X plus 3. Okay, then creating a graph. Okay, so let's go in the graph. And remember, we're going to start at 3. So we go to 3. And then the slope is 4, so that means we're going to go up 4 and then over 1. Up 4, over 1. And that's pretty much all the points we can fit on this graph. Okay. Now notice how I've been connecting all these lines, right? Okay, that makes sense for most situations, but sometimes it doesn't always make sense to connect all the dots. Okay, we'll talk about that later. Okay, so now we've done an equation, we've done a graph. Okay, and what I want to do is label the axis here. Okay, so it's saying that every 4 inches, or every week, it's growing at 4 inches. So in general, when we talk about time, that's always kind of our indicator of what our x is. We're going by weeks. And usually the B is going to tell you what your y-axis is. So this is the feet or the height of the tree. So your B, you can always look to see, okay, if my B is feet, then that's what my y-axis is. And then the other factor that they're talking about here is going to be your weeks. Okay, so now there's one issue with this, and that what I just noticed is that here, this is actually going up by inches. But here it says feet. Those are 2 different measurements. So what I realized here is I actually have to convert this. So let me actually start over here. And we're still going to keep this as feet. So what we need to do is convert the inches to feet. Okay, well, now let's think how many inches are in a foot. Well, we have 12 inches and equals 1 foot, right? So that means that we have 4 out of the 12 inches that it's growing each week. So the way we write that out is like this. We'll do 4 out of 12 inches per week that it's growing, okay? And we're only doing that just because we have a difference in measurements here. So we got to make sure we're consistent. So now what I want to do with that is now let's reduce that fraction. We can divide both of these by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So we get 1/3, or 1 over 3, x plus 3. So that's our equation, okay, or our final equation. Okay, so now we're going to go over to the graph, and let's graph that. So again, I said start at 3. And remember, that's your rise now. We've got a fraction, so that's our rise. We go up 1, then over 3. Up 1, over 3. Up 1, over 3. So you can see it's a little bit slower. It's not as steep, right? Because, I mean, a tree you would expect to be a little bit slower growth. Up 1, over 3. Okay, and then there's our line. Okay, so now it says to make a table. So I'm just going to make a quick little table here. And remember, we started at 3. X is always 0 for your first value. And then we're adding 1/3 every time. Adding 1/3. Okay, so how would I do that here? Well, what I can do is I can just say like 3 1/3, 3 2/3. That's one way to do it. Or I can use Desmos. Okay, so what I'm going to do is add first 3 plus, and I go 1 divided by 3, which gives me that third, right? So it's 3.3. Okay, so 3.3 for the first one. After 1 week, 3.3, 1.33. Okay, and then I add 1/3 again. What I'm going to do is I'm actually just going to copy this and then paste it. The plus 1/3, and look, it's 3.67. Or basically, I'm taking that and I'm rounding it to 3.67. Okay, so 3.67. Okay, and I'm just going to keep going. Okay, so I'll paste again, and then we get 4. So I'll write down 4. Okay, And then, so again, after 3 days, I should be hitting 4. Okay, so Angela planted a tree, or planted an apple tree in her backyard. When she planted the tree, it was 3 feet tall. So that means that's where the tree started at. Is she started with a 3 foot tall tree, meaning that's our B, our starting point, or our y-intercept. She notices that it has been growing 4 inches every week. Well, if it's growing, that means it's a positive increase of 4 inches every week. Okay, so that's going to be our M. Now, what I want you to notice is that the she got the tree and it says 3 feet, whereas here it says 4 inches, right? Those are two different kinds of measurements. So when we look for the slope, we're gonna want and the y-intercept, we want those types of measures to match, right? So here, let's use feet. Okay. In other words, I'm gonna have to convert these inches into feet. All right. Well, I know the conversion because I always remember that a ruler is 1 foot, right? And most rulers are 12 inches, okay? And 12 inches equals 1 foot. Okay, so that means that we have 4 inches out of 12 of a foot. Okay, 4 out of 12 inches in a foot. Okay, so that means what I'll do is I take that number and I put it over 12 because I have 4 out of 12 inches, and then I just reduce that. Divide that by 4, and again, this is our slope that we're looking for. Divide both of these by 4 to reduce it, and we get 1/3. Okay, so now we should be able to make our equation because that's the first thing it asks us to do is create an equation. So y equals 1/3 x, and then plus 3 feet is where it started. So there's our equation. Okay, so now let's graph that. Okay, well, before we graph it, let's go ahead and label our axis. Now, you always know what the y value or what the y-axis is going to be when you look at the y-intercept or the b value. And it says 3 feet, so that means that the y-axis is going to be your feet. And then the other factor that they're using, if you look at the slope, inches every week is going to be your x value. And usually when you see time, like days, seconds, weeks, months, years, whatever, that's usually going to be your independent variable or your x value, okay? Or your x-axis. Okay, so now what we'll do is we're going to start at 3, like we would on a graph. And now our rise is 1, and we're going over by 3. Okay, now be careful because if you notice on the bottom, the scale is going by 2, so pay attention to that. So we're going to go up 1 and then over 3. 3 is actually right here in the middle because we have 2 and 4, so it's in the middle of that. So we're going to go up 1 again, and we're adding 3, right? So we should be going to 6. We go up 1 over 3 to 9, up 1 over 3 to 12. And you notice it starts to kind of create a straight line, right? So we know where we're going. Up 1 over to 15, up 1 over to 18. Oops, sorry, 18's there. Okay, and then you might be able to fit in like 21 there. Up 1 and then 21's about there. Okay, so then just complete your line, connect the dots, because it is a growing tree that grows constantly. Okay, so now we've got our graph, all right? So the question is, sorry, next thing we're gonna do is make a table. Okay, well, at x equals 0, the beginning, we were at 3. And then every week, let's do like 3 more points, okay? At x equals 0, it's 3. Then after 1 week, we add 1/3. Okay, well, how do we add 1/3? Well, what you could do is you guys can go to Desmos, and let's do 3 plus, you can click on this little function here to get the fraction, 1/3, or 1/3, and we get 3.33. So let's write that in our table. Okay. Now what I'm going to do is I'm just going to copy this so I don't have to type it again and add another third. So it's 3.666666, and that will round up to 3.67. Okay, then I go back to the table again, add another third, and I get 4. Okay, so we'll stop there on the table. Okay, so you got an equation, you got a graph, now you got a table. Now, when will it be 6 feet tall? Now remember, the feet is your y value, right? So when will this graph get up to 6? When will the tree get to 6? So all I do is I go to the y value of 6 and kind of work my way over to the graph until I touch it. So then it's right here, and I got to go down to the x value that it lines up with, which would be 9. So that means in 9 weeks, okay, it will be 6 feet tall. Okay, so make sure you line up your own graph. So how can you see the growth in each representation? Okay, so the growth, so we're going to look at the equation, the table, and the graph and say, where do we see the growth? Okay, well, in the equation, it's the slope. Okay. In the table, I can see it in the increase in y. Actually, hold on, let me write the table first so we know what we're talking about. Actually, I'll do it down here. So the table, it's the increase. Actually, let's not say increase because it could be a decrease, right? We'll say the change in y. Because what if it was going down the other way, right? That's not an increase. Okay, now in the graph, it's pretty much just kind of like the equation, which is the m, it's the slope. So we see the slope or the steepness of the graph. Okay, so it's the slope of the graph that shows us the growth. Okay, so now state possible inputs and outputs. Well, remember that inputs just is talking about x. What are the possible x values, and y value, and outputs are the y values, right? Now think back again. Last week, inputs were pretty much all our domain, and outputs are a range. So that's really what it's asking for: is what's the domain range? Okay, so let's go to the graph. Well, let's start with the inputs. Remember, that's your domain, right? So how far left can it go? Starts here. And it starts at the x value of 0 and then just keeps going forever to the right. So that means that we can have values that are either 0 or bigger or greater. So that means x is greater than or equal to 0. Okay, now how about the range? Well, the range, remember, is your y values or your outputs, and it starts at 3 and it gets bigger than 3, right? It keeps growing past 3. So that means that y can be greater, can actually, it can be equal to 3. It can be greater than or equal to 3. Okay? Okay, let's go to the next page. Okay, so now Karen got a pet snake as a birthday present. On her birthday, the baby snake was just 13 centimeters long. Okay, she has been measuring its length weekly, so every week. That's a giveaway right there, probably for what our x value is going to be, the weeks, and the 13 centimeters is where it started. So let's actually circle that. That's going to be our b, because that's where it starts at when she got it on her birthday. And has noticed that it has been growing. Oh, we know the slope's coming when we see that word growing, approximately 3 centimeters each week. Boom, there's our m, or our slope. Okay, so we're going to do the same multiple representations. So first, let's get into the table. X equals 0. At x equals 0, we have 13. Then after 1 week, and we're talking about weeks, we're going to add 3 centimeters. And remember, notice how the measurement adds is the same now. We're going by centimeters in both the slope and the starting point, so we're good. We don't need to convert it. Okay, so now plus 3 after 2 weeks, plus 3 again. I'm just going to go ahead and finish this part of the table, and I'll finish into the left. Okay, so there's our table. Okay, then let's just go ahead and make the equation before we do the graph. Okay, so our m is 3. Our b is 13, so 3x plus 13. There we go. Okay, and then let's put it on the graph. So first, let's label our graph. Remember, we noticed that we saw weeks. And The giveaway for the y-axis was the b value. It says 13 centimeters, so centimeters in length. Okay, so now I can either like follow the equation, start at 13 and go up 3 over 1, or I can just plot these points that I have over here. So that's what I'll do. And you could actually, it might have been a better idea to actually go by 5. So what I can also do, I'm going to make another table. And this time I'm going to go by 5s because I want to have points that I can plot right here. Okay, because that'll be useful to me. So first I'll start with that at 13, right? Okay, then at 5, after 5 days, okay, so remember each day we're adding 3, right? So in 5 days, you're going to add 15. Because we're talking about how many will add in 5 days. Okay, so basically all I'm doing is taking the slope and multiplying times 5. So add 15 now. So 15, that'd be 28. Then how many after 10 days? And let's just go like maybe 2 more, about 2 more. Over 2 more x values. So now add 15 again, we get 43, then 58. Okay? And then we should be able to kind of figure out the slope by just looking at the graph. So now 0 and 13, 5 and 28, somewhere there, 10 and 43, okay, then 15 and 58. And then notice I can kind of start to form a line. Let's try to keep it as straight as possible. Obviously better if you use the ruler so you can really see where these points are at. Okay, so now the question is, if the snake continues to grow at the same rate, when will it be 1 meter or 100 centimeters long? Okay, well, on the graph, and let's just make an estimate real quick. So when will it get to 100? Well, there's 100, and we'll kind of trace our way over. So somewhere around like 30 days, okay? So we'll say about 30 days, but that's not an exact number. So what we're going to do is we're going to use the equation to solve it and actually find the exact day. So remember, that's the y value, right? We want to know when will it be 100. So what I do is I take that y value and I plug it right into my equation into the y. So I take out the y, I put 100, and now I just basically solve this equation. So here I take away my b on both sides to solve for x. Okay, so then this would be 87 equals 3x. And then divide both sides by 3. Let's pull out the calculator. Oh, there's a clear all button. Let's go 87 divided by 3, and we get 29. Okay, so that means that when will the snake be 100 centimeters long? In 29 days. So pretty close guess, right? 30 days, 29 days, but that's the exact and that's the estimate. Okay, so sketch a few different squares of different sizes. I know yours is equilateral triangle, which by the way, equilateral just means that all the sides are the same. Okay, so as you're making your triangle, kind of use that idea. Remember that, even though I know I'm doing squares, a little bit different. Okay, so anyway, sketch a few different squares of different size. Okay, so let's make a little one. I'll make a little bit bigger one, and I'll make a really big one, the best I can. And I'm just going to go ahead and give this a number. So let's say that's 2, right? And that's, I don't know, 4, and we'll just say that's 6. Okay, that each side, that's the length of it. And you know that a square, all the sides are the same, right? So that'll be 4, that'll be a 6, all the way around. Okay, so now create a table. Okay. And a graph and equation of the function with inputs that are the length, the inputs, remember that's x, the length of one side of the square. So this part is just the length of one side of the square. Okay. So remember, if x equals 0, if the length of one side of the square is 0, that means that there is no y. Okay, because the output is the perimeter, right? So if I'm going to find the perimeter of these shapes, remember the perimeter is adding up all sides. So triangle, you're adding up 3 sides. Square, you're adding up 4 sides. So here, if the one side is 2, then the perimeter is 8. So add up all the 2's. If the one side is 4, then the perimeter is 16. And if one side is 6, then the whole thing's 4 sixes is 24. Okay? So there's my table. And again, I had to start with 0, 0 because if you have a 0 length side, then you have a 0 perimeter. So now a graph. So let's make a little graph where we'll kind of do like this, because we don't need the whole like coordinate plane. We just need kind of like a half of it or a quarter of it. And it's going by 2's over here, so let's go by 2's. So 2, 4, 6. And we only have 3 values to the left here and 0 in the middle. Okay, then it's going up by, looks like it's increasing by 8 here on the y-axis. So let's just go by 8. So this will be 8, 16, and then 24. Okay, so 0, 0 is the first one. That's right in the middle. Then 2, 8, 4, 16, and then 6, 24. Okay, so we'll make our line. So there's our graph. All right. This is the length of one side. Sorry, you guys probably do a better job reading room for this. And then this is the perimeter. Okay. And then the last part is make an equation. Okay. Well, first we got to find the slope. Okay. To find the slope, we can do that a couple ways. We can look at the table and notice that the change in the y is 8. It's increases by 8. And then the change in x is 2. So I put that on the bottom. So that means 8 over 2 is 4. The other way I can see that is by looking at the graph. I start here at this point, and to get to this point, I have to go up 8. There's your 8, the rise, and then over 2 in your run. So it's the same thing. And then your b is where we started, which is at 0. So y equals 4x plus 0. I could write 0, but it's not necessary, so it's just y equals 4x. Okay? So now the last one. All right, so Michelle was given $190 for her birthday. Each week she spends $20. So she was given $190 on her birthday. That's probably the beginning. So she started with that. So that's a B. Sorry, you can't see that. That's your B, the 190. And then she spends $20 on going out with her friends. Each week she spends $20. So each week, meaning that's her M, all right, or how much she's spending. Now notice when you spend something, you're losing money, right? So this is going to be a minus 20. So we're decreasing the amount of money she has. Okay, so let's start with the table. So at week 0, she had $190. After 1 week, take away 20. And we're just going to work on the table all the way down. So we're just going to keep taking away $20 each week. And I'll fill in the X column here in a second. Okay, and then I get down to 10, and then I'm about to reach 0 down here. So let's fill in this part. So if I can't do 10 minus 20, right? So that means like I won't quite get to day 10, or she won't get to week 10 by the time she gets to like no money, right? Because in the question, actually, it says create a table of graph and equation for the relationship between the weeks since Michelle's birthday and how much money she has left. Okay. Actually, sorry, here's the real equation. The question: in how many weeks will her birthday money be gone? Okay. So if I'm looking at the table right now, it's somewhere between 9 and 10 weeks because at this point, I won't have any more money. Okay, so somewhere here, and I'll say about 9 weeks, she'll have no money, no dinero. Okay, so now let's do the equation. So y equals, now remember I told you the slope is negative because we're going down. so 20x. And then she started with $190, so we'll put it plus 190. Now let's go to the graph. Okay, so what I can do is I can just copy these points onto the graph or just follow the pattern of the equation. We start at 190, and then she's going down for every week. Notice how this is going by twos again, so we got to pay attention to that. For every week, she's going down $20. So here she's going from 190 to 170, and then here is 1 week. Okay, so down from 170 to 150, and then over 1 week, 2 here, and then here, 130 after 3 weeks, and then down to 110 after 4 weeks, down to 90 after 5 weeks. You should be forming like a straight line here. Okay, so down 6 weeks, down 20 again, 7 weeks, down 20 again, 8 weeks, and down 20 again, 9 weeks, and that matches up because after 9 weeks I have $10, and that's $10. So then it kind of comes down, and it's going to line up here somewhere. So let's go ahead and use like an actual straight edge this time, and make a nicer line. Yeah, I'm going to line it up and bring it all the way down to the x-axis down there. Okay. So I can't just keep going past the line because once you have zero money, that's it. It's not like she's making any more money, right? So it's somewhere, if 9's there, then it's somewhere in the middle of like 9 and 10 weeks. Okay, so that's where she ends. She had no money. She has no more money. Okay. Okay, and again, the reason I'm pointing this out is because that's part of the question is how does each representation show the solution to the problem? Well, I'm pointing out where that's showing that. Here, when it reaches the x-axis, or pretty much when y is 0, that's when she's done with money. And by the way, don't forget to label your axis. This is money, and this is weeks. Okay, and then where do we see that here? Okay, well, we can't really see where the solution is in the equation, okay, but we can see it in the graph, and we can see it in the table. Okay, that's it.